Foundations. Footings, foundation walls, pier and grade beam systems, basement walls, retaining walls, drainage and waterproofing, wall caps, slabs, garage foundations, utilities. What is a foundation? A foundation system has two functions. First, it supports the building structurally by keeping it level, minimizing setting, preventing uplift from the forces of frost or expansive soils, and resisting horizontal forces such as winds and earthquakes. Second, a foundation system keeps the wooden parts of the building above ground and away from the organisms and moisture in the soil that both eat wood and cause it to decay. What is foundation? The foundation is the part of a building that is most likely to determine its longevity. If the foundation does not support the building adequately, cracks and openings will occur over time, even in the most finely crafted structure. No amount of repair on the structure above the foundation will compensate for an inadequate foundation. Once a foundation starts to move significantly, it will continue to move. We have now developed the knowledge to design and construct durable foundations, so there is no reason to invest in a modern building that is not fully supported on a foundation that will endure the life of the structure. What is foundation? In the United States, there are 3 common foundation types. Each performs in different ways, but all rely on the perimeter foundation, i.e., continuous support around the outside edge of the building. Types of foundations: crawl spaces, slab on grade, basements. Crawl space foundations. Crawl spaces are found in all climates but predominantly in temperate regions. In this system, the insulated wooden ground floor is supported above grade on a foundation wall made of concrete or concrete block. The resulting crawl space introduces an accessible zone for ductwork, plumbing, and other utilities, and allows for simplified remodeling. Take a look at this detailed illustration. Slab-on-grade foundations. Slab-on-grade systems are used mostly in warm climates, where living is close to the ground and the frost line is close to the surface. The footing is usually shallow, and the ground floor is a concrete slab. Many slab-on-grade systems allow the concrete footing, foundation, and subfloor to be poured at the same time. Take a look at this detailed illustration. Basement foundations. Basements are the dominant foundation system in the coldest parts of the country, where frost lines mandate deep footings in any case. Like crawl spaces, basements are accessible, and in addition, they provide a large habitable space. Basement foundation systems are usually constructed of concrete or concrete block foundation walls. Drainage is particularly critical with basement systems. Footings. Footings are the part of a foundation that transfers the building's loads, its weight in materials, contents, occupants, and snow, and possibly wind and earthquake loads directly to the ground. Consequently, the ground upon which the footings bear should be matched by the size and type of footing. Please reference this detailed illustration on the right. Foundation walls. Foundation walls act in integrity with the footings to support the building. They also raise the building above the ground. The primary decision to make about foundation walls is what material to make them of. Take a look at this detailed illustration. Pier and grade beam systems. Pier and grade beam foundation systems are particularly suited to expansive soils or steep hillsides. They are also useful to avoid damaging nearby tree roots. Pier and grade beam systems must be engineered. Basement walls. Basement walls are 1 story in height, 7 feet to 9 feet, and are generally backfilled to at least 4 feet. A basement wall must resist the lateral pressure of the backfill at both the top and the bottom of the wall. Basement walls are therefore usually designed as if they were a beam spanning in the vertical direction, with the rebar located at the inside tension side of the wall. Take a look at this detailed illustration. Basement walls. Because the floor must resist the lateral force of the backfill against the basement wall, the connection between the wood floor and the basement wall is especially important. Retaining walls. Retaining walls resist the lateral loads from the bottom only. They rely on friction at the base of the footing and soil pressure at the outside face of the footing to resist sliding. The weight of the wall and weight of soil on the footing resist overturning. Take a look at this detailed illustration. Drainage and waterproofing. Drainage is essential in protecting a basement from groundwater, but waterproofing the basement wall from the outside is also vital. In selecting a waterproofing material, consider the method of application, the elasticity, and the cost. Wall caps. These details are for the tops of retaining walls, which are usually exposed to weather. Wood caps will ultimately decay, so they are designed for relative ease of replacement. There is not much point in moisture barriers since they only trap rainwater against the wood. Retaining wall surfaces should be protected from moisture penetration to prevent damage from the freeze-thaw cycle. Take a look at all of these detailed illustrations. Slabs. Preparation before pouring a slab is critical to the quality of the slab itself. The primary goals in preparing for a slab are to provide adequate and even support and to control ground moisture. Take a look at this detailed illustration. Slabs. Soil is the ultimate support of the slab. Soil must be solid and free of organic material. Some soils require compaction. In termite areas, the soil is often treated chemically. Gravel is a leveling device that provides a porous layer for groundwater to drain through from the slab. A minimum of 4 inches of gravel is recommended. Gravel must be clean and free from organic matter. Crushed and ungraded gravels must be compacted. Slabs. Moisture barrier prevents moisture and retard vapor from moving upward into a slab. 6 mil polyethylene is common and works well in detail A. Overlap joints 12 inches and tape the joints in areas of extreme moisture. A more substantial concrete-rated moisture barrier is necessary for detail B because the moisture barrier is in direct contact with the concrete slab. Polyethylene may deteriorate in a very short period in this situation and is easily punctured during slab preparation and pouring. Slabs. Sand allows water to escape from concrete in a downward direction during curing. This produces a stronger slab. The American Concrete Institute recommends a 2-inch layer of sand below slabs. Welded wire mesh (WWM) is the most common reinforcement for light-duty slabs. The most common size is 6x6, W1.4 by W1.4, adequate for residential garage which requires a stronger slab. Slabs. Rebar is stronger than welded wire mesh. A grid of number 3 rebar at 24-inch OC is also adequate for a residential garage. Fiber reinforcement is a recent development in slab reinforcement. The polypropylene fiber reinforcement is mixed with the concrete at the plant and poured integrally with the slab, thereby eliminating difficulties with placement of the reinforcement material. The addition of 1.5 per cubic yard of concrete produces flexural strength equal to WWM in a slab. Slabs. Extension joints allow slabs to expand and contract slightly with temperature changes. They also allow slabs to act independently of building elements with which they interface. Expansion joints are appropriate at the edges of slabs that are not heated, not in the living space, or that, for some other reason, are expected to change temperature significantly over their lifetimes. Expansion joints are also used to isolate building elements that penetrate slabs such as structural columns, walls, or plumbing. Control joints induce cracking to occur at selected locations. They are troweled or cut into the surface of a slab to about 1/4 of the slab depth and at 20-foot intervals. Cold joints, which automatically occur between sections of a slab poured separately, can act as control joints. Garage foundations. Turn-down footing at garage door. Garage foundations. Deep footing at garage door. Garage foundations. Garage slab or slab foundation wall. Utilities. Forced air duct in slab. Utilities. Plumbing through slab. Utilities. Radiant heat slab. Utilities. Polybutylene tubing has replaced copper tubing as the conveyor of hot water for radiant slabs. This elastic tubing is supplied in long rolls and can cover about 200 square feet without any joints below the surface. The addition of insulation below the slab will improve the performance of the system. Take a look at this diagram of radiant heat tubing. Foundation summarizing. Footings, foundation walls, pier and grade beam systems, basement walls, retaining walls, drainage and waterproofing, wall caps, slabs, garage foundations, utilities.